Hello friends, in today's session I am going to give an introduction to graphs, and we're going to talk about the different type of graphs that we have and how do we use them. So friends, let's first understand what are graphs. Graphs are basically visual representation of the numerical data. So if you look at this figure, this is some data being represented in the form of graphs. It's a visual representation which, just by looking at it, gives you an indication as to something is increasing continuously, regularly. Graphical representation is required because it's easier to understand, and they are very useful when we specifically talk about representing the trends and comparisons. So if you look at this figure, what we're saying is it is not specified what is this and what is shown in these bars, but if you just look at it, the size of the bars is increasing every time. So this just tells you that if this is how we are representing the trends, if you just want to compare, say for example, if you want to compare this bar with this bar, we can just by looking at the graph we can tell no, this has increased and by what percentage it has increased. So this is how graphs are really useful. So this is one type of graph that we had shown. This is another type of graph which is showing a continuous pattern, whereas this was not a continuous pattern, this is a continuous pattern. And then we have graphs of this type where we are talking about percentage. Now we'll be talking about each of these in detail. So first of all, let's talk about bar graphs. What do we mean by a bar graph? Bar graph is basically used to show comparison among data. Bar graphs consist of parallel, horizontal or vertical bars, as we just talked about in the previous one. So this is an example. Say for example, on this side we are saying games, on this side we are saying the cost. So we are doing a comparison. So now we can say that this dark blue color represents football, red represents cricket, green represents golf, and things like that. It could be any other. And then we are saying that we can compare the cost involved in these games by looking at these bars. So we are saying for the first bar we have the cost to be 3000. For the red one the cost is 4000. For this green one we have the cost to be 2000. So we are able to compare the data using the bar graphs. And now this is the ones that we've shown here are the vertical bars, but we could also make horizontal bars like this. So these types are also called bar graphs, and then we could have different colors over here. So this may be yellow and this may be, we could show it to be red and this could be a purple one. So these are two ways of representing the bar graphs. Now length of the rectangular bar is proportional to the numerical value that it represents. So as we just talked about this graph where the cost of the games is being shown by the bars, we look at the length of the rectangular bar and that will be proportional to the numerical value. So this longer bar is representing a higher cost and the smaller bar is representing the lesser cost. So this is where the bars are very useful. Now we can also draw bar graphs to represent marks of a few students. Say for example we have 3 students named ABC. We'll just take any names ABC, and we say here we have marks and we say student A received 100 marks, student B received 60 marks and student C received 120 marks. So we could represent the marks of different students using a bar graph. Another example could be we want to use this for different marks in different subjects of the same student. Say for example, instead of ABC we say maths, science, SST of the same student, and then we represent the marks by different bars. So these bars are used to compare. Now looking at this bar graph, we can clearly say that B received minimum marks whereas C received the highest marks of the three students that we talked about. And here we can also use multiple bars when we want to compare the marks of, say, two or more students in different terms. Say for example, we say that these purple ones are representing marks in term 1 of A, B and C, and the bars in orange represent marks of A, B and C in term 2. So we are saying now we have two different colored bars to indicate the marks in two terms. So we can use multiple bars also in the bar graph to represent the data, depending upon what is the data that we want to put in the graph and how do we want to compare them. So we just said that we can use two or more bars to compare multiple data. This is how we do it. This red and yellow ones will indicate it could be terms, the marks in different terms, it could be the change in the production of a crop or something like that. We could do, when we want to compare multiple data, we could use more than one bars. Now let's look at pie graphs. A pie graph is used to compare that part of the whole. So now this is a difference between bar graphs and pie graphs. Bar graph was used to compare data amongst each other. Pie graph is used to compare the part of a whole. So we are saying, if we look at this yellow colored pie, we can see that this is a small part of the whole. If we look at this lighter blue part, we'll say this is a big part of the whole. So pie graphs are used to compare part to the whole. And these are also called circle graph. Although the commonly used term is pie graph, but they're also called circle graph because they are represented in a circle. The circle is always considered to be the whole, and then based on the part of it, we'll call it a pie graph, and it shows how much part of the whole is it. Now the arc length of each slice or its central angle is directly proportional to the quantity. So if you look at, say for example, if you look at the yellow section, we say this is the arc length. This is the arc length of the yellow part. So this will be directly proportional to the quantity, to the part of the whole. So if we look at this light blue, we see that the arc length is much more than the arc length of the yellow one. So that indicates that this is a bigger part of the whole as compared to the yellow. And similarly, not just the arc length, if we look at the central angle, that also represents the quantity. So if we look at this yellow, the central angle is much smaller as compared to the central angle of this light blue, which is much bigger. So we're saying the central angle is also directly proportional to the quantity that that part of the arc is representing. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.